So C3, algebraic fractions, yay. Are fantastic because they look a little bit like numerical fractions in the way that they behave, but they're algebraic, and you know me, I hate numbers, so this is fantastic. Okay, so let's just go back to numerical fractions, so just your normal fractions with numbers in them, and think about what we actually do when we answer questions. So say for instance we're asked to simplify 12 over 18. Might seem like a simple idea, but actually think about what you are doing. Now, I know that the answer there is 2/3. I can do that almost straight away. And the reason I know that is because 12 over 18 is actually 2 times 6 over 3 times 6. Now, because both of the 6's are multiplied, so we've got 6 multiplying to the numerator, 6 multiplying to the denominator, I can cancel them out, leaving me with 2 over 3. So that's the key. We normally just jump straight from 12 over 18 to 2/3. We kind of do the divide by 6 in our brains. But it's because both the numerator and the denominator are being multiplied by 6 that we can remove them from the numerator and denominator respectively. Okay, so keep these methods in mind when you're dealing with algebra. Okay, when we add, we need a common denominator. Now, normally, the easiest thing to do is multiply the two fractions together. But obviously, if you can think of something that's a simpler, a smaller number on the denominator, that's going to leave you with smaller numbers on the numerator, which is obviously quite nice. In this case, it's going to have to be 24. There's no other options. So, what we've done there is we have forced the denominator to be 24 in both cases. Now, to get 24 on the numerator on the 1/3, I had to multiply it by 8. And I can't change the fraction. I can't change the amount that I have there. So if I've multiplied the denominator by 8, I'm going to have to multiply the numerator by 8. And similarly, I've multiplied the 8 by 3 to get 24. So I'm going to have to multiply the 3 on the numerator by 3, giving me 9. Okay, now I've got 8 parts of 24, add 9 parts of 24, which is obviously 17 parts of 24. Now, if that could be simplified, I'd encourage you to simplify it. Obviously, you want things as neat as possible. We don't want nasty, large numbers. Okay, multiplication then, really quickly. Multiply across the top, multiply across the bottom, then simplify if possible. So 2 times 1 is 2, obviously, and 3 times 7 is 21. Done. Dividing. Okay, what we're asking is how many 1/5 go into a third? Which is equivalent of saying I want to split a third into 5 pieces. So that's a bit like saying 1/3 times by 5. 5, don't forget, is 5 over 1, which is also 2 fractions. It's a bit like the case above, which multiply across the top and multiply across the bottom. So we're going to end up with 5 over 3. Okay, so numerical fractions, you've been doing them since about year 7. You should be well versed in them by now. If you're not, you must go back and practice them. The reason you need to get good at these is because in C3 it builds on the stuff we've done in C2. And so if you're a little unsure about the stuff we were doing in C2, you need to make sure that you are much more confident, because obviously it all just tries to build on itself. So I know some of you are going to be looking at this fraction here, 6x plus 3 all over x over 1 plus 2. Oh, 1 over x plus 2, and freaking out a little bit. Now, I'm freaking out a little bit, but I think I'm freaking out for a different reason. My reason for freaking out is that there's a double fraction in there. So there's a fraction within a fraction, and that makes me feel a little bit sick. So let's get rid of it. Okay, how can I get rid of it? Well, I know that 1 over x times by x is 1, hopefully. I also know that, say I had 2/3 and I multiplied it by 6, top and bottom, I get an equivalent fraction. So I haven't actually changed the value of the fraction, but I have changed the numbers. I'm going to use these two facts, okay? I want to get rid of the second fraction, the fraction within the fraction, and I want to make sure I don't change the value of the fraction I have here, the algebraic one. So let's multiply everything by x. Everything by x. So the top becomes 6x squared plus 3x. And the bottom, well, 1 over x times x is 1, and then we've got plus 2x. That doesn't look much nicer to me at this stage, except for the fact that the double fraction's gone, which is obviously a priority. So let's simplify. How can I simplify? Well, the whole point about simplifying was finding a similar thing, well, the same thing, top and bottom, that's been multiplied so that you can cancel it out. So like our times by 6 on our first slide. So let's factorise the top, because that's the only way I'm going to know what is multiplied together in that. So I can pull out a 3, and I can pull out an x, because they're both common to both parts, leaving me with 2x and 1. Oh, look, just move those around the other way. They're added together, so it's commutative. I can swap them around. And I'm left with the same factor there. This is basically 1 times 2 lot x plus 1. It's one lot of it. And then I've got 3x lots of it on the top. So I can cancel those out, leaving me with just 3x. So it's really interesting how that disgusting fraction up there really was just 3x. We had to do a little bit of work to get there. We had to go a little bit around the houses and kind of make it look a little bit more messy. But that helped to simplify it out. You probably wouldn't have gotten there straight away. So as long as you're using the rules of mathematics correctly, you can do whatever you like to try and simplify down a fraction. And sometimes it just takes playing with it. Okay, I'm just going to introduce the concept, and we're going to come back to this in a second video. What happens when I have top-heavy fractions? So when we're dealing with numbers, when we're dealing with numerical fractions, what we'd look for is the number of whole ones and then what's remaining. So in this case, a whole one is made up of 4 parts of 4. 4 over 4 is 1, obviously. How many lots of that do I have in 7? Well, I have 1 lot and 3 remaining. So this becomes 1 whole one, 4 over 4, and 3 quarters. Which traditionally, of course, there is a hidden plus in there. It's 1 and 3 quarters, not 1 lot of 3 quarters or anything like that. So for now, I would suggest writing that plus in there, because otherwise you're going to think that's 1 times 3 quarters. I want to know what when I have a top-heavy fraction in polynomials. So don't forget, polynomials are these expressions in algebra that we're dealing with at the moment. How do you first off recognise a top-heavy fraction in a polynomial? Well, it's all to do with its degree. Now, if you are not remotely interested in learning anything new about mathematics at this stage, turn the video off now. You've known enough to pass your A-level. If you're a little bit interested in what I might mean by a degree, and no, I don't mean a university qualification in this case, keep watching. So, a degree. What is this thing that I'm talking about? Okay, well, all polynomials, so this is any expression that has sometimes x's, sometimes y's, but it is a certain expression like this. Okay, it describes a line or a curve, and it tells a certain set of properties about the numbers that it involves. Okay, the degree is the highest power, basically, in simple terms. In this case, the degree is 3. And this tells us quite a lot about that polynomial. So it tells us it's a cubic. So we know what shape a cubic is. It's going to have some sort of shape a bit like that. It could be a quartic, it could be a quintic if it is 4 or 5. It could be, if we ignore that term there and pretend it wasn't there, then we'd have the highest degree of 2, and we'd have a quadratic there. And again, if that wasn't there, we'd have a degree of 1, and we'd have a linear equation. So you're dealing with these things already. You know how to recognise linear, and you know how to recognise quadratic and cubic graphs, but you've never had it formalised to you, highest power. And when you get onto sum C4, which we will do later, you might be dealing with things that look a little bit like this. And so on and so forth. There could be anything in there. The degree in this case is the sum of the powers, and you want to choose the highest one. So you always want the highest one. So you sometimes have to go searching for it. Sometimes it's not easy. But in this case, you've got x and x, is 2, and y, which is 3. So your highest power is 5. So your degree in this case, presuming that your equation stops there, obviously, and that in that hidden ... you haven't got anything, your degree is 5. So a top-heavy fraction is one where the degree of the numerator is bigger than the degree of the denominator. So where you've got a quadratic on the top and a linear on the bottom, you would kind of recognise it, but there is a formal piece of terminology you can use to describe it. So just a reminder then, in the next video, we're going to look at 2 methods for dividing polynomials. And you've probably seen them before, but we're just going to go over them one more time just to make sure you're completely happy with them, especially given C2 polynomials.